Alright, so here we have our simplifying surds video. A lot of these questions are in the revision booklet that you were given, and I'm just going to work through a few of these now. So our first one is we're asked to simplify the square root of 162. Now, as I suggested to you, it would be very handy to have your square numbers written down on your page from say 1 to 144. So you can hopefully identify that a square number that lies within 162 is 81. So we can actually adjust this and change it to 81 times 2 within the square root. Now we know with our surd rules I can split that up into the square root of 81 times the square root of 2. That's not very straight. The square root of 81 we know is 9 times by the square root of 2, so my final answer becomes 9 root 2, and that's your final, that's where we stop, just there. I can't get this any simpler than that. And again, if you want to check these in your calculator, do the square root of 162, then do the square root of 9 times by the square root of 2, and you'll see that these two are actually the same. The next one I'm going to look at is 2 times the square root of 63. Now, for this question, again, have your square numbers written down somewhere on your sheet of paper, and hopefully you'll be able to see that 7 times 9 equals 63. So I can then change this into 2 times the square root of 9 times 7. So 2 times the square root of 9, again using my surd laws, I can then split this up. I know that the square root of 9 is 3. 2 times 3 times by the square root of 7. I can now do 2 times 3 is 6 root 7. And that's my final answer there, and that's where we stop. The next question that we're going to have a look at is one that involves some fraction, a surd divided by 2. Now, this sort of one, we want to look at just this top bit first, just this square root of 28. Now, again, if you have a look at your square numbers, hopefully you'll be able to identify that the square root of 28, the number 28 can be made up by multiplying 4 and 7, and then we're dividing all that by 2. Again, I can split this up into root 4 times by root 7, all divided by 2. I know the square root of 4 is 2. Leave my root 7 over 2. Now I have a number 2 here, I have a number 2 here. I can cancel them both out, and my final answer is just going to be the square root of 7. I do have a couple of more small videos, questions to go through. So the next question we're going to have a look at is where we have to add 2 surds. Now, when we have to add 2 surds like this, we need to get the surds in the same number. Now, we're quite lucky in this case because this one already has 7 root 5 plus 4 root 5. And in order to simplify that, I just need to add the coefficients. So 7 plus 4 equals 11 root 5. If you want to think about it in terms of algebra, we can think about it as 7x plus 4x equals 11x, because both of these are the same. Much like when we're doing our algebra with 7x and 4x, I can just add these together to get my 11x. The next question I'm looking at is 2 root 3 plus 2 root 7 plus 2 root 3 take 2 root 7. Now again, this is a combination of different surds. Now we want to see, can we change any of these? Root 3, root 7, root 3 and root 7. I can't change any of those. Okay, I can't get a square number multiplied by another number to put within that, so we just leave them the same. I'm just going to rewrite this though as 2 root 3 plus 2 root 3, as I've identified that there's one here and another one here. I'm then going to write plus 2 root 7 take 2 root 7, again because I have a 2 root 7 here, I take 2 root 7 here, and then I'm just going to simply combine them. So 2 root 3 plus 2 root 3, like our previous question, if our two surds are the same, I just add my coefficients. 2 plus 2 is 4, 4 root 3, and then here I have positive 2 root 7 take 2 root 7, which gives me 0. So my final answer becomes just 4 root 3. Alright. Again, if you want to compare this to something we might already know, think about it as the original equation, this one here being 2x plus 2y plus 2x take 2y, and as I did with my surds, I just identified my like terms here and here, and then here go 2x plus 2x is 4x, and 2y take 2y is 0, so this would be my final answer. Again, this is not to be confused with how we do the question. I'm just relating our surds question to some form of algebra that we're hopefully familiar with. The next question we're going to have a quick look at is this one here. So this one's a little bit harder again. Alright, again we have negative 4 root 5 take 2 root 15 plus 5 root 15 plus 2 root 5. And like we did with our previous question, we need to identify terms, our like terms. I have some coefficient root 5, another coefficient root 5, so those are both like terms, so I'm going to write them together. Negative 4 root 5 plus 2 root 5. I'm then going to look at my other two, so I have root 15 and root 15. So again, I'm going, because they are also what we would call like terms, I'm going to put those next to each other just to make things a bit clearer. And then much like our previous one, I just go through and work this out. So negative 4 root 5 plus 2 root 5, so I go negative 4 plus 2, which becomes negative 2 root 5. Put some equals so we can follow along. And then I have negative 2 root 15 plus 5 root 15, which then becomes positive 3 root 15 as my final answer. Now you might be looking at this 15 and thinking, oh, maybe I can change that, maybe I can get a square number out of that. But if we think of all the numbers that multiplied equal 15, we only have 1 and 15, which neither are square numbers. 1 technically is, but we don't use 1. And the other two numbers to multiply to get 15 are 3 and 5, which again, neither are square numbers. So quite often we'll be left with a surd that looks something like this. Now the last question I'm going to go through was a question that I went through today in class but didn't get to finish. So when you're asked to find the perimeter and area of a shape like this, now again I started going through this one in class but didn't quite finish it, so I just wanted to go through that one now. So hopefully we can identify that this is a right triangle. So I need to find this side here, C. Excuse the scribbling, I made a small mistake. Now in Pythagoras, to work out this hypotenuse, this longest side, we need to use our formula a squared plus b squared equals c squared. Now I'm just going to label this side as my a and this side as my b in order to calculate this question. So I need to do root 8 squared plus root 2 squared, which is going to equal my c squared. Now as we've identified, hopefully, the square root of 8 squared just becomes 8. And the same as when the square root of 2, when we square all that, actually cancels out each other. So it's only 8 plus 2 equals c squared. We know 8 plus 2 is 10. So I can end up getting, therefore, c equals the square root of 8 plus 2, which equals the square root of 10. And that's my final answer for C. Now that I've got my length of this side here, alright, the square root of 10, I can now add these together to get my perimeter. Now, before I do that, I need to look at whether I can manipulate any of these to get them all in the same sort of form. And if I have a look at side A, my 8 centimeters here, I know that A I can make up with 4 times 2, 4 being a square number, square root of 4 times the square root of 2, which is only 2 root 2. So now I have a 2 root 2 here, and I have this root 2 here as well. Now this is where we got a little bit stuck today when I was explaining this question, and whether or not we can manipulate this question here, whether we can manipulate this 10 into getting it in some form of root 2. Now the only way we're going to get it into some form of root 2 is if we use 5 and 2, but again 5's not a square number, 2's not a square number, so I can't use those, and the same, I can't use 1 and 10. So I actually leave this one just as it is. So then my perimeter over here is just going to equal A plus B plus C. So I end up going to get 2 root 2 plus B, which is root 2, plus C, which is root 10. Combining these two here are like terms because they both involve a root 2. 2 root 2 plus root 2 becomes 3 root 2. And then again, this is like an unlike term. This doesn't match up with anything, so I just leave it on the end and get plus 10. Sorry, the square root of 10 centimeters. And again, if you put this into your calculator, 3 times root 2 plus the square root of 10, you'll get some decimal answer for centimeters for that one there. However, in this case, we are just going to leave it in our surd form. Now, the last bit I need to do is we are asked to find the area of the shape. Now, hopefully we're aware that the area of a triangle is equal to a half base times height. I just wanted to slide this up a little bit. Now, the base of my triangle is this bit here, my b, so root 2. So I'm going to get a half times by root 2. And then I'm going to get my height, which in this case is going to be a. So there's root 8 here. But we've actually identified this to be 2 root 2. Now I'm going to show you 2 ways to do this, using this value to start with. So now I have here a half times base times by the height. Now what I'm going to do, I'm going to just combine these two to start with. A half times by 2 times by the square root of 2 times 2. So I've just moved this to here. This has stayed here, and I've combined these two ones here. Now, a half times by 2, let's slide that up a little bit more. I know 2 times 2 is 4. A half times 2, I know the square root of 4 is 2, which is then going to give me a half times 2 times 2, or a half times 4, and I know that a half of 4 equals 2 centimeters squared, being my final answer. Now, as I said to you before, I'm going to show you another way how to do this. Alright, so our other way of doing this would be, again, area equals a half base times height. I have 1/2 times my base, root 2, times by my height. But this time I'm going to use this one here, the square root of 8, and I'll show you how that gives us the same answer. Some people might prefer it this way, some people might prefer it this way, it's completely up to you. Now again, using my surd law, I can combine these two things to get the square root of 2 times 8. 2 times 8 is 16. Hopefully we're aware the square root of 16 is 4. So we're getting a half times 4, which equals again 2 centimeters squared.